Alright, so we have a two-part question for question 3 here. We've got two functions h and g, both all in the real numbers, and we're writing them as a piecewise function here. So the first one is the absolute value of x plus 1 in absolute value. So we should first find the breaking point. So when is this equal to 0? It's going to be when x is equal to minus 1. So that's the breaking point here. We know that that's going to make the function value, or h, 0. And here, the slope here we can see is just going to be positive 1. So we check that the scales is 1. So 1, 2, 3, 4, 5, yep, in both directions. So we can use the diagonals very nicely like so. And we know the absolute value is also a reflection. So that line x plus 1 would continue ordinarily like so. But we know that the absolute value makes the function values positive. So all of these values will be reflected up in the x-axis, and we should be careful to draw along the diagonals here as neatly as we can. Let's draw an arrow to show that this continues, because remember, we're talking about real numbers. Okay, so let's look at part B now, where we'll graph the function g. So here we've got an absolute value combined with some extra variables. So when we see the absolute value here, we should first decide what the breaking point is here to make this 0. So we should see that the breaking point will be when x is equal to 2. So this is an important point. It's going to have a different function value for when it's less than 2 and when it's greater than 2. So let's work this out. If it's less than 2, then this whole, maybe let's draw a little diagram like this. So we've got x equals 2 here, less than 2, and greater than 2. So here we should see when it's less than 2, this value is going to be negative. For example, if x is 1, then that makes the inside minus 1, so it's negative. So we should make the inside, then we know that the absolute value makes this positive. We should include this as negative x minus 2. And then the rest of the function as well. So plus x, let's see if I can fit this in, plus x minus 1. Alright, so if we simplify this, we have x minus x. Well, positive x and minus x is going to cancel. We have positive 2 minus 1, so that's going to give us 1. When x is bigger than 2, for example 3, then the inside's positive, so nothing changes here. It's just x minus 2, and then the rest, plus x minus 1. So this will simplify to, we got 2x and minus 3. We should check also what happens at 2 itself. So when we have 2, we have g of x would be the absolute value of 2 minus 2 plus 2 minus 1. And so here this would be, what would this be? 0 plus 2 minus 1, 0 plus 1, it's equal to 1 at 2. So we can write this whole thing, let's do it in formal piecewise notation. So here we would have, let's say the first, we have the function is equal to 1 when we have x less than 2. And actually we checked the value at 2 here was also equal to 1, so we could say that x is less than or equal to 2, if the function value is 1. And then it's 2x minus 3 if we have x bigger than 2. So let's graph that here now. So let's graph this section here on the left in red. So we're starting at x equals 2 here, and we're taking the value of 1, a solid line to indicate that it's included. Of course, if we remember back here, we're looking at all real numbers, so we have no gaps in our graph. And to show that, let's go right to the edge of our graph and draw an arrow to show that that continues. Now for the second part, 2x minus 3, well, let's just graph it normally. If we were going to do that, we would start at the y-intercept, which is minus 3. So down here, minus 3. And the slope of 2 means that as we go across to the right, we should go up 2. Cross 1, up 2, cross 1, up 2, continue that pattern. And that actually happens to go through the same value as the other section of the piecewise function. So here, again, the arrow to show that it continues. There should not be any gaps here. Let's see if I can just tidy that up. And we don't need this scribble part over here. And so we've graphed the functions. The important part in both of these examples was that the very first step was to find the breaking point. So where this function was equal to 0, we found it was -1 here, and in the second example we looked here and found the breaking point was 2.